Peter. Can everyone hear me okay? Can everyone hear me in the back? Cool. So tonight my talk's about unlocking serverless observability. We're going to go on a serverless integration journey. We're going to talk about a fictitious company and how people get started with serverless, and then we're going to talk about what we should really be considering to increase our observability up front when we start. So that's what I'm going to talk about tonight. So as you heard, I work for Accenture. I've just recently joined the data and AI practice because of restructures. I do a lot of inward focused work with product in the product area, and I do a lot of serverless acceleration, which I've been focused on for the last 2 years with a lot of teams. I'm an AWS community builder in the serverless stream. I co-host the AWS Programming Tools Meetup in Melbourne, and yes, my hair's grey. I witnessed the birth of the internet as an adult. We're going to talk through today. We're going to talk about what I think about observability. What is observability from my perspective? What are the things we're going to focus on today? We're going to meet Alice. We're going to talk through Alice's use case and then look at what she built and how she went about building that, which is probably a common story. How many people are building serverless today? How many people are running in production today? Lots of people. Who's an expert at doing serverless? Good answer. I don't think anybody is, not even me. I think we're all learning still. Then we're going to sum that up with about unlocking serverless observability. What do we need to focus on? And then we'll do a wrap up and a few little references. So to start with, I want to talk about what is observability. Did that change? No. That changed. So what is observability? For me, this nasty triangle, thank you, Midjourney, nasty Illuminati, observability pyramid. Midjourney's great. I think all my images are from Midjourney, so thank you. So really, I'm going to talk about the traditional logging, tracing, metrics. They're the three things that we really need, and we'll talk about why we need those as well throughout the journey. To me, for observability, the key is being able to ask questions about your system and infer answers. So it means you need enough data to be able to ask questions of your logs or investigate your metrics to come up with information about what's actually going on with your system. I really feel that logs should tell a story. I say must. I really think they must. So I really encourage the teams that I work with to make sure that your logs just aren't stupid things, but they're actually things that make sense, things that you can link together, things that you can put into a time stream and actually make sense of. And we'll go in more into that with some examples later on. I think it must be structured. You want structured logging? Everyone does structured logging? Anyone just do console.log? That's okay. It's a good place to start. You've got to start somewhere. You can console.log a structured log. That's effectively what happens, but must be structured. And we'll talk about why and what you can do with that. And hopefully there's some key takeaways, or maybe you're already doing all these things. Metrics. I really honestly think metrics is probably, I think as developers, we're used to running on servers where we're good at the technical metrics. We're not so good at emitting custom metrics about business KPIs. And I really feel from an observability perspective, it's the business KPIs that we really need to focus on. I think custom metrics is something that we don't, as developers, think about because we're not in that business sense. But I think design-wise, we should be thinking about that to keep that going. And lastly, we've got traces. They're important. They give you performance data. Who uses X-ray? Who understands what X-ray is and how to use it? Good question. Good feedback. That's the feeling I get generally, is that X-ray is a very, what can we say, difficult thing to understand, difficult beast. And not a lot of people use it, which is why there's probably like 200 odd plus observability providers out there in the market today in the serverless world. They keep cropping up every month, I reckon, at the moment. So that's what I think that's what I think for observability are the key things that we should focus on. They're the key things I'm going to talk about, and we're going to talk about the whys. We're going to talk about that within the context of Alice. So here's Alice. She's a cloud engineer at Widget Inc. She keeps the lights on for the e-commerce website. She runs the weekly sales report. It can only run weekly because this e-commerce system runs on a large EC2 and it's at capacity. So there's issues there, right? So there's problems. It's a common business problem that we all have. And Alice works really, really hard. As you can see, there's lots of, I tried for Midjourney to give me Dr. Pepper, but it doesn't write words, I found out. Here's Max from sales. Max needs view of orders as they happen. He's really angry about it. He has to wait a whole week to work out what's going on. He's not happy. So Max from sales and marketing is not happy. And they're also bringing on a new delivery partner. So that gives us a problem that Alice has an e-commerce system on an EC2 that's at capacity, that she needs to be able to have an API integration and also data integration out to a third-party reporting tool that Max uses. But she doesn't want to introduce new code. But fortunately, she's looking through the code, as you can see in the picture, and she noticed that the e-commerce site had a webhook available. And so she thinks about this and goes, well, I've been learning about AWS, I've been learning about serverless. And she jumps on to serverless land and goes, I'm going to learn about event-driven architectures, because this is a key classic use case of an event-driven architecture that can be used to solve the problem without necessarily adding any more code to the EC2. So it becomes a nice solution that she can use to expand on. So she goes for serverless land and starts reading about event-driven architectures. So serverless land is very AWS oriented. Doesn't have to be. Serverless land, the event-driven stuff is brilliant. The work that David Boyne's doing there is brilliant. It's just all event-driven. So it's not really focused on a particular cloud or technology. So I'd highly recommend reading that information. So she goes off and reads that. She also goes off in serverless land. There's if you drop down the drop down of code, you can actually look at patterns. She finds a common pattern. She goes, "This is an event pattern. That's what I need. I'm going to go build that." And so that's what she does. And I feel that this is the way a lot of people, when they're first coming to serverless, they go, "It's serverless. It's a Lambda function. It's just a function. It's not complicated. I get some data in, goes through an event bridge, it goes through another Lambda, and we do something." There's things as developers we need to think about, and that's what Alice starts to do. She starts to think about, well, how can she do this? She's got this pattern, she can clone that, she's got the infrastructure as code ready to go. So half the problem's there. She just needs to write the specific business logic so that she can get to business value really fast. And that's what the serverless promise is from the cloud, right? Get to business value fast. And that's what she's doing. That's what she wants to do. So this is what she built. She built exactly that pattern in two streams. So she built out the API gateway, bit of an API, Lambda there to process that, an event bus, which basically disseminates the order notification to two Lambdas simultaneously, which is really efficient and cool, right? It's really easy. It's a classic event-driven pattern, a classic delivery pattern of doing data integration. Today we're going to focus on the delivery API. So we're going to focus on the delivery of the data to ACE couriers, and we're going to focus on that stream today, just to constrain the conversation, because otherwise it's the same conversation really. So she goes off and starts coding up and building. She's decided that she wants to use Python because she knows Python. That's the language of choice. There's a lot. Who uses Python here today? A lot of people. Python's a good language. I love Python. So she codes this up with Python. Now, what I've shown here is she's built up her API delivery. So it's called try API delivery. That function there is what the core of the delivery API. She's wrapped that with an at retry decorator. That's using a tenacity library from Python, which enables any function within Python to be redriven really fast. It's from the Apache Foundation. It's a really powerful tool to enable any function to be redriven internally. So it allows, if that API call fails or throws an exception, the tenacity library will rerun that a number of times. There's a fixed wait time with a random wait time, so it's going to wait anywhere between 3 and 8 seconds. There's a bit of jitter. So we're doing a little bit of variation of our wait time to try and, if there is a capacity problem on who we're talking to, we can deal with that. And she's thought about all these things to make it work, which is good. Retry is good. Random wait times and jitter are good. So she's also using a logging framework. She decided to use Lambda Power Tools for Python to do a logging. That's a really powerful. Does anyone know about AWS Lambda Power Tools for Python? A few people. It's really powerful in the fact that it's going to give Alice structured logging out of the box. And as we know, structured logging is important, but we'll find out why in a couple of slides. We'll talk about why that's so important, because I think the why is really important to understand. One of the powerful things that you notice here with the Power Tools is, as we define the logger, we can actually define a correlation ID path. Now, when we do integration work, you want to be able to trace information from one system to another, and that's usually done with correlation IDs. Does everyone know what they are? Correlation IDs, transaction IDs. It's really important, right? We need to be able to track the data from where it came from to where it goes across all of our systems. And that's what she's thinking about here. So that's what she's built. And as you can see, it's very simple. It's not difficult code. The handle is very, very simple. It just goes through and grabs some stuff from the API body that's been sent, the body that she gets from EventBridge, and then goes off and calls at the bottom, just does the response equals try API delivery right at the bottom. And so there's no retry code here, which is nice and simple. Tenacity is just naturally doing that for us through the function calling mechanism of decorators in Python, which is, I think, is quite neat. It means your code becomes really simple, which is great. What she actually ended up building, and I actually built this. I actually went and built this, so I wanted to actually demonstrate today. I've gone and built this. So I've built the notification API, an EventBridge bus, and a delivery API with some configuration from secrets manager for the API key and the API endpoint. And what I've done is I've simulated ACE couriers, and I've actually built what I call a slow API. It's a slow API, and it's built to be a little bit slow. It responds in a random time between 1 and 10 seconds. And randomly 20% of the transactions that go through the API are going to fail. Just so we can see what happens. What I want to showcase today is what happens when we have a system. We've thought about retries, we've thought about some structured logging. What happens when we start actually running that at scale? And what actually happens? What do we see from an observability perspective? And how do we know when things are going wrong? And maybe everyone will smirk when they see one of the graphs I'm going to show. Everyone will go, yeah, I've seen one of those, hopefully. Maybe, maybe not. So that's what I've actually built, and that's on GitHub. I'll share that at the end of the night. I'll make sure that's up and available so you can actually go and run it. I'm using Artillery to run. I used Artillery to run the tests. It runs for about 33 minutes. Does 3 minutes, a minute of warm up, a couple of minutes of ramp up, and then slowly over the next 30 minutes, slowly ramps up to go over the inbound system limit of ACE couriers, which is set to about 10 TPS. And at the end, I think after about 15 minutes, the artillery test is pushing through about 15 transactions per second. And we can see what happens. And it's interesting to see what the graphs do. So what happened to this when I ran a very vanilla architecture, lifted directly from serverlessland.com. It's a very authoritative site. What happens when we just write our code and deploy it and run it at scale? So what happens? We start at the beginning. So on the left-hand side, you see the green line's good. Red line at the bottom, that's good at the bottom at the start, but as it goes up, that's bad. So this is what a classic metrics graph of percentage success versus error rate looks like at scale when your Lambda is going wrong. Because when your Lambda goes wrong, it backs up. And if you've got other Lambdas that depend on that Lambda, you're going to get a big storm of problems that are occurring. Has anyone ever seen a graph that looks like that? Yeah, there's a few people. Good. So, but interestingly, I've actually found this is a really interesting exercise. And I want to talk a little bit about that before we get into the detail. As we go across the graph, the first few minutes, there's nothing happening. Then we're slowly ramping up. And it's not until we reach around about this point here where our errors are going up. Errors probably sit around about 80 errors in a 1 minute window. That's kind of 1 error per second coming out of the delivery API failing. So it's failing and going back. Now, because we're driven by EventBridge, if that Lambda fails, we've already retried 5 times. We've got to retry internally 5 times. And then it fails. EventBridge is going to execute that because it's asynchronous 2 more times, which is great. It means that there's natural resiliency. So if you imagine just naturally, we've got 20% error rate, which is why you're seeing the dips, even at low volume, you're seeing a few dips. We've got 20% failures. And they're actually being redriven by AWS naturally. So natural resilience is kicking in. Serverless is naturally resilient, and it's more resilient than we think. So even at 20% failure rate, even when we're running at 10, we're running by about the zero mark about here, we're probably running at about 10 to 12 TPS. So we're already exceeded what the API can do, but still we're getting success, which is kind of cool. It just means naturally the resilience of a natural low volume. If you go and copy a pattern and you've got a low volume system with nothing else going on, you can actually deploy that pretty quickly and it'll work. It's not until you start getting to scale and start getting issues where you've got what I call a scalability boundary, high scale going to low scale, Lambda going to a server system, that's the scalability boundary, that we need to consider and look at that. So that's what's going on. That's what I want to highlight here is with these graphs. And the new one from AWS these days is the async events dropped. That's a really cool one. That's a new graph. That's really useful. You can alarm on that when problems go wrong. And as you can see, it went really, really wrong. And as you can see, as the delivery API started failing, all of our retries built up, and you can see the concurrent executions start creeping up on the left-hand side, which is also what happens when things go wrong and you've got retries, and basically we end up in a retry storm. So vanilla, with a few retries, we go, yeah, I've done the right thing, I want to retry, but it's not always exactly the right thing to do, not all the time. Something to think about as you're architecting. But I want to talk more about, well, here we are, that's how we can find out what's going wrong. I also want to talk more about, well, what actually went wrong? And there's three things that I pick out with this architecture that's wrong. The first one is there's no flow control. We're doing data integration. So if you want to do data integration, no matter where you are, whether it's on a server or if it's serverless, you need some sort of flow control. That needs to be introduced into the pattern to make that work. We've got a scalability boundary, and that scalability boundary is what causes the clash and the errors because there's no flow control. And the other thing we have is generally there's poor visibility of what's going on in your code, or confused visibility. People who are new to serverless are confused about where to look and what to look at. So I just want to highlight a few things when thinking about integration is, things that I know from my experience of teams who do data integration, especially whether it's serverless or not serverless, or whether it's on Azure or AWS or Google Cloud. People don't understand what their system volumes are. I often turn up to programs that are not quite going right, and I turn up and go, well, what sort of volumes are you expecting? And nobody knows. If you don't know what your volumes coming in are, how do you know how to control the flow? How do you know that if you've got a system downstream with a rate limit that you're not going to exceed that? So understand your system's volumes, understand the downstream constraints. Are you going to be rate limited? Is there a limit? Is there not a limit? What's their maximum capacity? Those questions, hopefully, everyone can answer. And add in flow control, introduce correlation ID and transaction IDs into your logging, and also make sure you're doing structured logging. And that's what I want to talk about next, is really get into structured logging. I've got one quick slide about the fixing of the architecture. That's how you fix the architecture. You introduce SQS. SQS is fantastic. ESM is fantastic. I'm not going to talk about that. That's a whole new topic to talk about. That's how you can fix it. You've got high scale on the left. You've got flow control through the SQS queues, which actually enables controlled scale going forward. Sure, it might take a while to finish all the work because of the scale difference, but it won't fail in exactly the same way. I intend to put that up as a branch on the GitHub as an example of how it behaves once that's been fixed. So I'll put that. So what does good logging look like? This is what Power Tools pushes out by default. There's a lot of cool things I really like about what Power Tools does. It's JSON formatted, it's structured. It has some really key things that get logged, like the service name. Service name is really powerful. It enables you to have 3 or 4 lambdas that exist within your environment that can log the same service name. That's then searchable. You can now have a logical group of lambdas that represent a microservice, because that's what we build, right? We build microservices constructed of 1 or more lambdas, right? So 1 lambda is not the thing we need to log. It's the thing, like we might have a notify handler. Maybe there's 2 or 3 lambdas in there. If you have the service name across those, naturally, you'll be able to search those and group your logs. It's all about, structured logging is about grouping your logs, searching your logs, and being able to see what's going on. And I think that's the most important thing. That's the thing I encourage the most with new teams for serverless, is getting that structured logging. The other interesting thing about Power Tools is, and AWS specifically, is the X-ray trace ID at the bottom. You don't need to turn that on for that to turn up in the logs. Because by default, AWS trace everything. The trace goes through everything naturally. And it's not until you turn X-ray on, you can't see anything because you haven't turned it on. It's not being sent to the X-ray service, so you're not getting visibility in X-ray. But even if you don't turn it on, you're still getting this trace ID. You're still getting that information in your logs from Power Tools. I've noticed that. That's really cool. So even though you're not getting the visibility in X-ray, you're still getting the benefit of being able to search through your trace within your code. You won't get the timings, you won't get all that cool stuff that X-ray does, but you're getting visibility of what's going on, which is really helping. The power of structured logging, this is lifted straight out of CloudWatch Insights. So I did a quick query, and you can notice as soon as I expand a log entry, which we're just looking at notify handler start, processing auto notification, that's the query I did to pull out the timestamp, the service, what it was doing, and it lists out all of the fields that are in the logs. All those fields are searchable. That's why we want structured logging, because in CloudWatch Insights, you can have up to 20 log groups at the moment. Maybe that's enough, maybe that's not enough. In a small system like this, it's enough. But there are other strategies of taking CloudWatch logs and actually disseminating those or aggregating those into a single. I've heard of AWS talking about, AWS solution architects talking about, well, you can just take CloudWatch and have subscriptions that combine them all into one CloudWatch place that you can search. And you've now got aggregation using natural cloud tools with no third-party add-ons, no Splunks, no other tools. I'm using Splunk because I'm from Accenture and they love Splunk. Just saying. Yeah. Well, I talked earlier about, we want to talk about our logs to make a story. And this is an example of what I tried to pull out is what I did was every log message has a start, a complete, and a failed log. And that's really powerful for getting a list of what's going on. As you can see from this, it's gone through the notify handler, which has worked. It's gone through the delivery handler, which started. It went to the slow API, because that's part of the chain of we're doing in the same account. And then it failed, the slow API failed. But then we get the slow API restarting again. So the retry mechanism within the code has worked. So we can actually know we can actually look. This is another thing we can do is we can actually take a search and search through using CloudWatch Insights and look at the starts in notify handler and the completes in delivery handler and see in a time period if there's a mismatch, we've got a problem. In this example that I did in the tests, there was a huge mismatch because I was pushing way too many transactions. So I was causing it to fail deliberately to highlight those graphs and see what those graphs would look like. So to unlock serverless observability, in my view, we need to think about observability. We need to think about the story our services need to tell. And we need to think about what we're going to write in our log messages. It's not just random things or variable names. We need to have constructive things. So I always encourage my teams to, a lot of the projects I work on, we build out middleware handlers for TypeScript that go off and do the logging in the middleware. So we get the start, we get the fail, we get the complete, because we can tell those things based on the response from the service. So you can do those things naturally as a framework and get them into every piece of code. So developers don't have to worry about that little bit. So you can do that bit for everyone else. So you don't have to, rely on everyone doing the right thing, because it's really hard getting every developer to understand. I work in teams where there could be 10 people, there could be 5 people, there could be 100. And when you're in a team of 100, getting everyone on board and aligned is not so easy. So frameworks are really important, and I always push frameworks for that. Log your transaction and correlation ID. Prior to late last year, I always, for integration, would inject the correlation ID and transaction ID into a metadata value within the body of whatever I was pushing through the serverless system, because the body of your data passes through every service naturally, including SQS, because as we know, X-ray trace IDs never pass through SQS until, I haven't tested that. Maybe I should test that. But they delivered it.
It works.
It does work. Just checking, because it's AWS, right? But that's what I did. That was the simple thing. I wrote about this 2 years ago. I wrote about observability with zero code. If you just inject that if you create events as an integration language internally in your systems, and then you just need to write adapters for in and outs, you actually track everything across your system naturally through your logging with just pushing those into your body. Key metrics, like I mentioned, track metrics per Lambda, sure. Duration, I think, is the most important one. A lot of government jobs I work on, they're really busy accounts. Your Lambdas are pushed into a VPC that has Kubernetes clusters that run a lot of other stuff, and they have their own network control, and working in government is really hard. And I actually found that tracking duration was really important, because that becomes latency in the cloud is what kills everything you do. Like, latency is your enemy in serverless, in my opinion. So you can put anomaly detection with CloudWatch over the duration of all your lambdas, and that uses AI to detect and normalize over about a week or 2 weeks. It'll normalize what every day looks like. And as soon as you get one or two standard deviation variations, you can actually have alerting go off, which is powerful, because then you can work out the problem's coming before it's actually occurred. And I think that's powerful. And I think if you're not doing that, if that's the only takeaway you have tonight, I think that's awesome, because it's a faster indicator of impending problems. And anomaly detection is awesome. And think about business. Think about what the business needs to say, is everything working? Is my serverless system working? Because at the end of the day, observability is about, am I comfortable that what we built is working? It's easy to do in development at scale when you've got thousands of transactions per second running through a system. If you can't query your logs to work out what's going on, then you've got no idea what's actually happening. As an example, the government project last year, we did a 3-hour soak test through the serverless integration system, and I was able to pinpoint one transaction that was dropped across that 3-hour test. I could actually query the logs, and we worked out there was one guy got lost, and I could prove it. And I was disappointed because I told my developers it was a bug that needed to be fixed, and they didn't fix it. But anyway, that's another story. So as a wrap up, that's how I think we should unlock serverless observability, is look at CloudWatch, look at insights, look at metrics, do structured logging. All those things are critically important. I use Lambda Power Tools for Python today. I use SAM CLI in Python. You can find me on Twitter, Mastodon. I'm currently building out Serverless DNA at serverlessdna.com. It's a new knowledge portal I'm trying to build out. And of course, if you want to learn more about serverless, serverlessland.com is good. But take their patterns with a grain of salt and actually apply it to your use case and make sure it's going to work properly. Thank you.
Thank you. Any questions for Michael? One question. Somebody has one. Well, I have a question. Oh, yes, please.
How do you decide where the right place is to put retries? Because I saw that you had retries in the code. Also, like you mentioned, Lambda retries.
Yeah, so that's a hard one. That's a very use case dependent, right? I've always there's two schools of thinking. I think there's trade-offs for both. So I often, when I first started doing serverless, would go, you should actually, if you need to redrive something, the infrastructure is what drives the code. So I feel the infrastructure should do the redrive, will be responsible for the redrive. But you can also get a little bit of benefit from actually retrying within your code. And that's a pattern I'm seeing, just working with the Power Tools group. And there's a lot of people do the retries very quickly because it is reasonably quick. But then that exacerbates things because your infrastructure should be driving the code. And there's two schools of thought. And I think it's you really need to think about. I'm kind of changing my thinking a little bit. But I think I was going for what most people do. And what most people do is that. But I think infrastructure driving your code is what I would push more purely. Does that answer the question? Kind of. Yeah, there's lots of trade-offs, right? It's hard. It is hard.
I have one question as well. So I use Lumigo, which is a third-party paid tool for observability, and I feel it's nice because you get real-time alerting, you get really nice way of searching for your logs, etc. You get kind of the nice visual tracing, like X-ray as well. Have you had any experience with it? Have you looked at it? And how do you compare that tool to, I don't know, just going natively with AWS?
I wish I could use tools like that. In my experience, I work a lot in government, I can't use tools like that because of exfiltration of data is not allowed. So that's the only reason. That's why tools like Lumigo, Honeycomb, and Baselines are now a thing. Datadog are doing really good. New Relic, there's a whole lot of things. I think Lumigo is a great product. I worked really hard to try and convince the powers to be at Accenture that we should adopt that as a pattern because it is powerful. So there are a lot of third-party providers out there. I tried to steer away from that today to focus on, if you're just starting, you've got enough on your plate to learn all of that stuff. There's a lot of stuff. But yeah, I agree. Lumigo is a great product. I really like Lumigo as a product.
Thank you.
And I like the work they do, and all the providers. Because I was just talking to Michael O'Brien as well. They built a tool called SenseDeep, which is quite interesting, and it comes back to immediacy of information. Because as we know, if you rely on CloudWatch is probably a little bit behind.
Pretty terrible, you could say.
It's quite so, which is why it's eventually consistent. Which is why you need to tell a story in your logs, because when something goes wrong and you're only using CloudWatch, you're like CSI. It's a forensic investigation. And you need the data to work out what the heck went on, right? Or to be able to tell that story. And that's why I say logs should tell a story, for that reason. Because then you can actually work out what goes on. Because if you build a system, where it should go. You've got the checkpoints. You know where it should go. And so using the story idea with start, completes, fails, you actually get a very clear indication of what's actually going on in the system. And that's what I think is needed when you don't have those tools to unlock what's going on with observability. But even those tools may not always, you might get some errors, but you might have redrive happening. So errors in serverless don't actually mean things failed. That's the other point as well. So it gets complicated quickly.
That's is success.
Absolutely.
It'll eventually work.
It'll eventually work.
One last question.
You mentioned that you use AI to look into the logs to find a problem.
You can use, I mentioned the anomaly detection, which is a feature within CloudWatch that enables you to take a metric and apply, they call it out. It's basically a statistical analysis of your data. The model will adjust itself to what your regular transaction cycles are, and then after about 2 weeks, it becomes quite reliable, and then you can alert whenever your durations go, wherever your metric goes, deviates by 1 or 2 standard deviations from what the norm of your system operation is, which is a powerful way of working out when things are going wrong, especially if you're in VPCs and they get busy and there's Kubernetes and there's gateways and there's a whole lot of other things in those environments. When you've got a really busy VPC that your Lambdas are in, you're sharing network bandwidth with everybody, and it becomes durations and latency are really heightened. So that's why flow control is so critical, because your latencies, you have no control over that. It's all managed services. And you need to be able to bend and sway with that. So CloudWatch anomaly detection is what the AI work is.
It's already building.
Sorry?
It's already
there. So I focused on what's already there, because that's where we start. But Lumigo's a good option. SenseDeep, Baseline, Datadog, Honeycomb. Are there more? Dynatrace. There's thousands of them. Hundreds. New Relic.
All right. Thank you very much.
Thank you.
Oh, we got pizza.